Okay, welcome everyone. I'm going to just quickly share my screen here to get started. Go. So welcome to our 5th lockdown event. And I hope wherever you're joining us from, you're nice and comfy. Here in Durban, it's a bit gloomy and it looks like there's a storm on the way. And I hear a lot of our friends in Johannesburg are anticipating one as well. So this definitely seems like the best place to be, or the safest place to be, and enjoy some good content from our speakers today. So as always, we've got a large number of our team online today. They can be helping moderate our questions and answer anything that you've got. So on the right-hand side, feel free to drop any questions during the session, and we might pick some up during the talks or after. Now, very quickly, looking back at some of the events that happened in September, the Safe at Home hackathon had kicked off. Registrations right now are currently closed, but the hackathon is still ongoing, and a lot of teams are working on some pretty cool solutions to the scenario that was proposed to them, and we're pretty excited to see what they come up with. And the deadline for submissions and teams will present the solutions around, I think it's the 19th of October. So I'm pretty keen to see what comes out of that. Then looking forward to October and towards the end of the year, and it's pretty interesting. There's a ton of events happening, and there's going to be quite a few slides highlighting some of them, and it'd be cool to see some of you attend these. So for the month of October, the first one coming up is Xamarin Expert Day on October 2nd. This is going to be, again, all Xamarin, completely virtual again. I've been really enjoying all the conferences that's been happening. I think this has been a record year for me attending conferences. Just Ignite was last week. Traditionally, I'd probably only go to one a year, but I've lost count at this point, which is pretty cool. Next up is the Global Biz Apps Days. That's on the 31st of October. You can sign up for this. A ton of topics covered. I barely can understand most of the stuff. I see Azure, so I'll attend this one as well. But there's plenty of in-depth topics here if you're into Dynamics 365 and Office 365. Now into some of the .NET stuff leading up to .NET Conf in November. We got .NET Dev Summit in October as well, October 31st. And then, as I alluded to, November is going to be a pretty big one for .NET, with .NET Conf 2020 happening, November 10th to 12th. And this is going to, well, the big ticket item here is that .NET 5 is launching with tons and tons of new features there. It's a really exciting release. I've been trying to keep up, but there's just so much that I want to play with. So that's going to be a very interesting one. And then now a very interesting platform that's coming through is the Power platform. We've got Power Africa happening 5th November. This is going to be very interesting to see what we can do with Power platform, and specifically for the African continent, how we can leverage all the opportunities emerging with that platform. Again, another Xamarin one, MonkeyFest US, Everything Xamarin, November 21st. And then one from our team here, from the MS Doug United team, we're looking at hosting the Global Microsoft 365 Developer Bootcamp, November 21st. And then sort of looking ahead to the next MS Doug, just a sort of a teaser before we get on to tonight's speakers. For the October meetup, we've got the CTO from the Una platform giving us an intro to open source Una platform. Then we've also got Roma going to show us how to build our own bot in a very quick session. That'll be very interesting. And then lastly, we're going to have Gordon Beeman as well, showing us how to think or rethink our application boundaries using Cloudflare. And then again, just before I go on to tonight's speakers, a reminder that on the right-hand side, there's a little section there where you can post all your questions, and our moderators, if they can't answer it, we'll table it for the speakers and we'll get to them. So feel free to, throughout the session, drop your questions in there. And finally, what you're here for, today's speakers, we've got some very interesting ones. And first up, we've got Gerald, who's going to be talking about Codespaces, developing anywhere from your iPad browser, VS Code, or pretty much anywhere. As you said, that's going to be very interesting, not having to, I personally like the idea of not having to carry my big, hefty developer laptop all over the place, being able to code from anywhere. Then next up, we've got Quentin with an introduction to Docker. Personally, for the longest time, I've just sort of hacked my way around Docker, and it'd be really good to have a nice introduction into it. And then lastly, for tonight, rounding it off, we've got Dustin going to take us through Stateful Serverless with Azure Functions, which again is a very interesting topic. Serverless has been ramping up and taking over enterprise development recently, so I'm very interested to see what's happening there. And while our first presenter, Gerald, is getting ready, I'm very quickly going to do an intro. I'm going to bring this up. So Gerald is a software engineer at Microsoft, all the way from the Netherlands. And he has many years of experience with Azure, ASP.NET, DevOps, Xamarin, and other .NET technologies. And as much as he likes to code, he's also very passionate about spreading knowledge, which makes perfect sense because he's here tonight sharing that information with us. And like most of us, you can find him all over the internet. He's got a blog, he's answering questions on Stack Overflow, and open source projects in his spare time, and then Twitter. So Gerald, I'm gonna hand over to you.
Great. So hello. Should I be doing something else than just unmuting and start talking? I haven't used Teams before, but seeing the reactions, I see people can hear me, so that's great.
Yes,
all right,
so feel free. Yeah, you can share your screen.
Start my screen. Yeah, here we go. I don't know what is this team stuff. All right, let me get this out of the way. So Codespaces, and I have some slides as well. Codespaces, yeah, like you said, great intro. Thank you for that. Lots of pressure on me right now. So, whew, here we go. Codespaces, developing from your iPad browser, Visual Studio Code, or anywhere basically. So we're going to see how that can. I mean, I don't even know how it works. It's pure magic. It's pure magic. We're going to see it, and I'm working on this stuff. So don't worry about it. All you need to worry about is the code. So that's the cool thing. A little bit about who I am. Again, you got a great intro already. So I'm working at Microsoft. And I'm mostly showing this because, here's some contact info. So if you have any questions after this or on something, excuse me, or on something Xamarin related, because I'm on the Codespaces team right now. But before that, I was working at the Xamarin Forms team and the Xamarin Expert Day. I'm just going to plug it right again. I'm the organizer of that, and it's going to be very much fun on Friday. So make sure to join us. You can find all my handles, other things on the link that's there. And I'm publishing a lot of stuff these days on my YouTube channel. So if that's the way you prefer to learn stuff, mostly on Xamarin actually right now, subscribe there. And, one day I can just stop working at Microsoft and be a big YouTube influencer. That's my dream, man. That's what I want to do. All right, enough about me. So a little thought experiment here, like on your new job, how quickly can you get to coding? We've all started a new job, probably, hopefully, at some point. And it just takes time to get your environment up and running, right? I mean, the first problem is usually getting your accounts to work, to log in. That's something Codespaces is not going to help you with, but it is going to help you with getting all the SDKs installed, getting Visual Studio, that ginormous gigabytes of things that you need to download. To do that, I see a lot of Twitter messages, like in South Africa, if you're joining from there, that there's power outages and whatever. Well, this is going to be nonsense. I was going to be like, that's not going to bother you, but it's still going to bother you because you don't have internet, and then this is still not going to work. So forget about that. But it just takes time, and this is just one scenario. You can come up with other scenarios, right? Like I've seen one scenario where maybe you are doing a job interview. Heck, the job interview I did at Microsoft was remotely because I'm remotely from the Netherlands, and everything was remotely. So. And instead of doing like some whiteboard thing that everyone hates, you can now just spin up an IDE, join as the interviewer and the interviewee, and you can actually write code, compile code, see if it does the thing, solve a problem, and you get the job. So that's going to be awesome. And there's other things like, from the top of my head, there's probably at a lot of companies, there's a machine under the desk that no one should touch because it's configured precisely for that one legacy application that is still running, and no one can touch it. No one can do ever updates anytime. So you can just take that, put it in the cloud, and only spin it up whenever you need it. So that's just a couple of scenarios that you can do with this. So that's really, really cool. And I'm not like overstating things whenever I say that you can get up and running to coding on your first day on the job within a minute. So that's what we're trying to solve. That's what I just explained. So if you think on like what is a dev environment, then it's all these things, right? It's all these cogs that need to be in place to work together before you can be productive. So it's the editor, it's the source, it's all the runtimes, all the different .NET versions and stuff. If you're working with Xamarin, it's even more fantastic what you all need to install. You have the debugger bits, you have all the packages that you have installed or need to have installed, all the tools. You have a bit of terminal to glue it all together with those all these command line things, and you have a bunch of extensions that you probably love to use. So that all makes up for your dev environment. And with Codespaces, we are going to take all this pain away, and you can just focus on your project and you. So that's all we want to do. We want to make you happy. That's what this is all about. So let's talk a little bit about what is then Codespaces. So it's a managed environment. So it's like a containerized dev environment that runs in the cloud. So you're probably used to, I'm going to assume that most of you are .NET developers or in that ecosystem, or at least you know about it. So you're using Visual Studio 2019, and you know, that's a monster. I mean, it's a great tool. It's one of the best out there, I think. I mean, I'm not biased at all, but I think it's a great tool, but it's enormous because you can do so much things with it, right? Because I said .NET developers, but you can do web development. You can do, I mean, outside of the .NET ecosystem, you can do all the React things, all the JavaScript things. So there's a lot you can do, but that also means a lot has to be in the package. And this environment is managed for you. So I like to do these kinds of sessions, record videos on my YouTube, do all kinds of other things, and that might interfere with whatever I'm doing with my day job, right? So I have preview bits installed, and tomorrow I need other bits to do my actual job. And with these managed environments, that's very easy to switch because you have just containerized environments that you can throw away. You can spin up a new one. It will be exactly as you have configured it. It doesn't conflict with any other things that you might have installed or not. So it's completely separated. That's very cool. You will feel right at home because there's a couple of things, as we will see in the demo in a little bit, that you can do a number of things to personalize these environments. So one of them is you can specify your own Docker file. I think we're going to hear about that in the next session. You can specify your own Docker file with all the bits that you want to have installed on the actual container that is spun up for you. So you can install all the bits, you can configure it the way you want. Another concept is dot files. I've never heard of it before I joined this team, but the dot files, I will explain it in a little bit more detail, but you can already see them here, like the little .git ignore and babel rc. With those files, you can configure your environment and personalize it. So you can have your terminal show up with the pretty things. You can have the terminal wishing you a nice day. I don't know. You can do all customizations in the terminal. Or what do you think about like the npm feed sources or the NuGet feed sources that might be private and you need to have them in there? You can drop those in a .files repository, and that will automatically be cloned, and all the files will be in the right place, and it will run the initialization scripts for you. And your dev environment will look and feel exactly the same as the one that you have set up on your local machine. So that's pretty cool. With all this, you can develop from anywhere because this is all, you can see that in the screenshot right here. This is running on github.com. So it's Visual Studio Code running in the browser. So I'm not going to go into all the naming things here because naming is hard. Also with Codespaces, because it started like with Visual Studio Online, which was already the name of like the actual Visual Studio Code client on the web, I think. And before that, Visual Studio Online was what is now called Azure DevOps. And so, I don't know, naming is hard. I wasn't going to go into it. So this is based on Visual Studio Code running in the browser, and you have the full experience there. You can do everything you can do with Visual Studio Code on your machine. You can do that in the browser as well, which is pretty easy because it's just like in TypeScript kind of thing app, right? So it was web-based to begin with, but you know, don't mention it. It's always like mind-blowing, full VS Code experience, very cool. So you have everything, so that's pretty cool, and it's all based around collaboration basically. So you can develop from anywhere, but a lot of this Codespaces stuff is is piggybacking on LiveShare. So LiveShare, for the ones who don't know that, is the service which allows you to invite other users to your IDE. So you get like the multi-cursor setup. I think you can have like 32 people editing at the same time, and they can help you out like whenever you're writing code, and you can attract their attention so they get pulled into a file. It's a very cool tool to collaborate remotely, and this all works together. So in your Codespace, you can also start that live share session, and you can work together from your iPad, again, whatever. So again, if we think of scenarios, it's all web-based, it's all running in a browser. So if you carry around just an iPad because you're on vacation to a safe place where there's no COVID, then and something breaks in production, the only problem you're going to have to deal with is probably your partner, who will be mad because you're working on vacation. But other than that, you could just take out your iPad and fix that code in production, and just do that without carrying around too much stuff. So all the info is on the link down here. You will see that link pop up a couple of times. Everything that I'm telling you today is in preview right now, so you have to sign up for it and get access first. I think after Ignite, things have been a little bit more open, so I think they're allowing a little bit more people in, so it should be easier to get in right now. Also, to address that a little bit, if you have been following this for a longer time, there was a thing called Visual Studio Codespaces, and now it's all GitHub Codespaces. So basically what that means is Visual Studio Codespaces is no longer a thing. The only way to access Codespaces for the foreseeing future is through GitHub. What that means for Azure DevOps support and that kind of stuff, to be honest, I'm just a simple developer on this product. I don't know exactly, but I mean, you can only guess that it should get some kind of priority, right? But for now, it's fully integrated into GitHub and doing all the great things there. So let's just have a look. Someone interrupt me if there are questions. I can actually bring up the Teams thing right here. Let's see if there is something. Can we expect Codespaces? Yeah, sorry. Were you going to mention that question? Codespaces with Maui and Xamarin support. Okay, great. So that is a good question. I think not for the foreseeable future. I mean, it's definitely, it's for me at least, it's an ideal scenario, right? Without installing all the bits that you need for that. So hopefully, yes. But there is one big challenge with that, and that is that for now it's very suitable for like the web development and console things and that kind of things. But you would have to have a way to somehow mirror like the simulator or the emulator running on the actual machine that's running in the cloud, right? So I'm sure that's something we will figure out. But I think the main focus is to get this concept like end-to-end working first with like the web solutions and the solutions that are more suitable without actually having a UI running. But I mean, I think the end goal here is to go for a full experience IDE that can serve all the workloads. So Xamarin.NET MAUI will definitely be one of them at some point. But I don't have any roadmap or plans or inside info, I swear. So this is the website that I just linked. So here is all the info, although it's not that much. I think it links to some docs somewhere in here. Here's a big button to request early access. So do that now. Well, wait after the session. Although you can multitask, right? So that's good. So request access. I'm just going to scroll down here for a little bit because there is some interesting bits here. There is some kind of little FAQ here down the bottom. So read that. How much does it cost? So that's always an interesting question. So at the time of the preview, it's free. You are limited to 2 Codespaces at a time. But there is some information on the costs right now, so go check it out. I mean, it's a cloud service. It's to be expected that there will be some cost, right? But it will be far less than than the machines that you can spin up with this if you have to buy them each year. So I'm just going to go ahead and go to my GitHub page. I have a repository, which is a very simple .NET Web .NET Core web application. And the cool thing is that whenever you get into this preview, you can already see like the Codespaces thing right here at the top. That is my overview of the Codespaces that I have running. In fact, let's just go there right now. And I have some fancy dev tools. You probably won't see those. But so I have this one. This is actually one that I'm using to create a GitHub action, which runs on JavaScript, NPM, whatever, just as an experiment for myself to see if that works, and it did. But this one is a .NET Core application, and the cool thing is whenever you get into the preview, you have this code button here, and you have that already, but you have the options like open with GitHub Desktop, which is the desktop client, open with Visual Studio, download a zip, and some instructions to clone the repository. Very cool. But it's all about this button right here, right? So you have the open with Codespaces thing, and I don't have any active ones, at least not for this repository. And I can just say, boom, new Codespace, and it's going to create one for me. So it's spinning it up right now. And the last time I did this, there was a little bug which takes a long time to get me into the actual environment. But typically, you should see that under like 30 seconds or a minute mostly, you should be in here in your IDE, and you should be able to be up and running. So it asks me, I think I'm still running into this bug because this asked me, and this is not the right theme that I want to see. So it takes some time to somehow reload this and get me into the actual environment. I'm not quite sure why that is. That shouldn't be something that you're seeing. It's probably because I'm linked up to some preview bits right here. But you can see this looks like Visual Studio Code right here. I'll zoom it in a little bit. I mean, there's literally no difference besides the fact that you can see this is running in a tab in my browser. I'm just going to start clicking here, see if that works. So you can see it cloned the repository, right? So I have all my folders here. I have the things that you would expect from a .NET Core application, like the CS Proj, the program CS, etc., etc. And yeah, I think I can start editing. So that's the thing. Always read only right now. So I'm going to give it a little bit of time while I talk about this is there's going to be a difference, of course, between this is a Linux machine. So here all the strategies come together, right, from Microsoft. So this is a Linux machine, and because .NET is now cross-platform, you can just run this from this Linux container. So that is pretty awesome. But of course, there are still a lot of things. If we talk like the future things, there's still a lot of stuff running on Windows. So we also have the Windows scenario set up. This Linux ones run on Docker containers, so they are very small and yeah, you can easily spin them up. So Windows machines are a little bit different. They are a little bit bigger. So you know it takes about the same time, surprisingly. And we do some nice tricks there, like you know, it spins up a full VM basically, and it has full Visual Studio on there. But what we do, like to take away some of the loading time, is to spin up 2 Visual Studio instances. So whenever you disconnect the first one and you connect again, you will connect to that second one and spin up one again. So just to take that load time away. So those are the things that we need to do for on the Windows side. But you know, it's still pretty cool and pretty powerful. Here you can see it reloaded in the background, so you can see it looks a little bit different. There is also a thing for the personalization part, like the settings sync, which is now an option in Visual Studio Code, and that syncs all your settings, all your themes, all the things basically. So also that comes over to your web browser, and you will feel right at home here. So it downloaded some things and extensions, very good. And I can now just go into it. Opens a README. So I think one of the goals of Codespaces is to eliminate the README basically. So because we don't need that, we don't need all these instructions to see how to set up our environment and do all the things, right? Because we just have the code right here. We can dive right in. But it opens a README because it will probably stick around this concept and have some useful information after all. So it opens that by default, but I can just you know, go here into my program CS. You can already see the light bulb of the IntelliSense coming up. So this is all there, right? You can see all these unnecessary using directives. I hate those. So let's just remove them. Well, there we have it, demo gods. Command not found. So this is not working for some reason. Oh, there it is. So this should just work normally on the first try. And whenever I start typing here things as well, you can see the IntelliSense comes up. The documentation should pop up here, and you can do all the things like you normally would. So in fact, let's just go to the. So if you don't know about Visual Studio Code, it's a very lightweight editor, and you have all these panes here on the left. So this is our file view. Here we can search for some things, our Git things, and this is the tab where we can just start running and debugging. So let's just do that right now without any change. Just boom, let's open it, let's run it. And you can see the terminal here at the bottom. Well, if you're working with .NET Core bits, this should look pretty familiar. It just start building my CS proj here, and it should come up any minute with a new tab that is running my web project. And then we're going to see an interesting thing. Oh, it blocks my pop-up. That's fine. No, it's not coming back. Okay, cool. Then don't. Wow, I'm learning this together with you. We have a Codespaces app, apparently. Okay, cool. So you just got this exclusive hint right here. So normally it should come up with a pop-up running my project, but in the output here you can see localhost 5000. So that's interesting, right? Because I'm not actually running on localhost. I'm running on a machine in the cloud. So I just have basically a thin client running on my machine, which is also in a browser. So even this is running server side, but you can also do this from the actual VS Code client or from Visual Studio 2019. So then you basically have like a thin client, and all the heavy lifting is done in the cloud, right? So how is this local host thing going to work? Well, it doesn't. Boom. There we have it. It doesn't. So they did a little bit of magic. So you probably don't want to do this. But if you go to command click this link, then it opens up a special magic link, and that loops back the port that we just saw and loops it back to like that machine. And suddenly we can access our application like we normally would. And this is a very simple. This is the project. This has some ASCII art with the AutoCAD and .NET bot, and they say some nice things. And whenever I say a message is hello from the Netherlands, awesome people, then it says that, right at his head, boom, in his head, balloon in his head, doesn't matter. So you can change this message. And this is now running there. So if I go back here, just to show you that this is like the real full experience thing, I can go into my pages here. I can go into the index. And I can just set a breakpoint here, right? Like it's going to check if there is a actual message, and if there's not, we have a couple of predefined ones. It's just going to take the first one from that, and else it will take like the query string that I just entered. So whenever I reload this now, so there are some subtle differences whenever you run this in a browser, because it's not probably actually able to focus that other tab, right? Because if that was an API in your browser, then all the spyware people would go nuts. They would love it. So what you can see happening is that we have this little emoji popping up here saying like, hey, you're running into a breakpoint right now. And if we go there, we see that we are actually in a breakpoint, and I can inspect all these things as you would expect from like the browser running locally, right? So that is pretty cool. You can just drill in here and see all the things, inspect all the things. Then when you're done, just say, OK, continue, and that's that. It's going to continue. Also, whenever this is specific to a web project, but also whenever we start changing things. So if I go into like the CSS here, and I think like, I know a name of some nice background color, I'm just going to make it Azure because, for no reason. I'm not sure. Oh, well, it's a subtle difference. So let me actually just make it red, so it's perfectly clear. So whoops. OK, so that's something you shouldn't do. Oh, no, I broke it. So I reloaded my my Codespace instead of my running web app. So now it probably lost the session here. So this is, well, the thing I was going to show you is that, you know, you can just make changes here, reload your application, and boom, you should see the changes just like it's running locally. So that is, that's all part of the experience as well. Actually, I'm gonna make it run one more time because I want to show you another thing. That is like, okay, this is all running online, right? So whenever you have this magic link, so it's red. Okay, let's Control Z this. Oh, I can't do that because I reloaded. Okay, cool. So back to Azure then. Save it, reload, boom. That works. So this magic link, so then that means that anyone can access it, right? Well, no, you have to be authenticated to actually do this. So whenever I go into an incognito tab, then you can go to this link and you will still have to authenticate first, and it will have to be your username and your actual account to be able to access that. So that is secure as well. I could imagine, I think, and there's where, by the way, the live share comes in. Whenever you share your session, then they will be able to join in on that as well. And I can imagine that there will be some way that you can say maybe like, hey, this debug session is public or something, so that you can easily debug with other people as well. I'm not sure if this is just a brain fart for me right here, but I could imagine that that is something that would be enabled at some point. So to make all this happen, under the debug pane right here, we also have like a new Codespaces thing, or they call it the Remote Explorer. So you can see the other Codespaces here at the top. You can see the details for this one. There's also a suspend that you can, it's a little bit left over from the Visual Studio Codespaces. And also this is more important for the Windows ones. So it has a timeout because, you know, you will be billed for the time that this thing is running. So you want to, whenever there's no activity, you want to suspend this as soon as possible to not incur any additional costs, right? And down here you can have the forwarded ports. So this is the 5000 that I was just running into. You can add new ones if you want. If you have added another project that's running on another port, you can just add them here and they will be accessible as well. Okay, what else? So that's pretty cool. So there's one more thing. Here in the menu, we have the terminal. So that's one thing that I mentioned, like in the personalization things, right? So you can see it wishes me a have a nice day here. I'll get into that in a little bit. And, you know, you can just see this is just you can do all the things here. So I can go to, I don't know, you can actually see the files that are cloned in my repository. You can go to the root here. So this is just a container. You can basically access all the things like you normally would, and you have full control over this thing. What do I want to do first? So the have a nice day thing, that's actually coming from my dot file. So that was, I didn't do anything, right? I just clicked the new Codespaces thing, and that is something pretty cool. So if I take this tab and I go to my github.com, my handle right here, and go to my dot files. So like I mentioned, the dot files is something, it's mostly a thing on Linux where you have like these dot file things. And whenever you have a repository in your GitHub account that's simply named dot files, which is apparently the typical thing that these people do, they just have a repository with dot files, and it will clone that automatically for you. It will find that, it will clone that, and you will have all the personalization in here. So, you know, in this little bash RC, which is the thing, a little bit of script that is ran before each bash terminal is spun up, it will just echo have a nice day. But you can do all kinds of personalization here. Maybe you have aliases set up for certain commands. You will just have them. You can use them inside your Codespace. We have the same thing. I've actually implemented a part of this for the Windows things. So again, it's mostly a Linux concept, but on Windows, we kind of mimic this stuff. Where you can run PowerShell files, and also profile.ps1 is apparently a thing which is kind of like the same thing for the bash RC. So this piece of PowerShell is ran whenever you create a new PowerShell terminal. And actually what I did here is like have the fancy Posh Git oh my Posh thing set up that Scott Hanselman is using in his Windows terminal demos and things. So it looks pretty, and it will show you like all the Git open Git things and whatnot. So you can all set that up here as well. So if I quickly go back to my Codespace, actually, let me go to in this Git tab right here. You can see I have some changes. This one, oh, this is cleaning this. Okay, so that's good. I want to have that one. I want to have this Azure background. Well, actually, let's not do that. So I can just discard changes. Yes. And I can just say, okay, remove unused usings. Here we go. And I think I'm not too familiar with the VS Code UI, but stage all commit, yes. So, okay, I can do that in my terminal. I mean, this is linked to the same thing, so I can do git status right now. I can't? Okay, so no, I have to go back to the repository thing, of course, which is workspace website, not website. Come on, .NET Web, that was it. Pull up. And I can now say git status. You can see that there's one commit, and I can now say git push. So it because it's linked to my GitHub account, it knows all my credentials, right? I could also do this with a private repository, no problem. It will know my credentials, so I can, all my Git things are set up here as well. I can just push this, and whenever I then go to, what was it called now, .NET Web? If I go there, you can see remove unused usings 1 minute ago, so that just works seamlessly, right? While I'm here, let's go into our dev container right here. So that's the thing I mentioned. If you want to like configure your environment, we have a thing. I think this is a actually a concept that exists outside of the Codespaces, the dev container, but you can use that here as well. And you can, there's probably some documentation that you can look up somewhere. So you can use this JSON configuration file to set a name for it. You can say how to build this thing. So you can specify your own Docker file with some arguments that you want to use here. You can set up the extensions. So one of the nice things that I found out early on is that whenever you go to the Microsoft Docs, and I wanted to fix, I don't know, a typo or something. So I went to the Microsoft Docs. I thought like, hey, I have access to Codespaces, so why not? I opened the thing in the Codespace, and the thing I noticed was that it installed, it's probably not here, but it installed an extension that is the Microsoft Docs pack or something, which has a couple of nice features that will give you some formatting of the Microsoft Docs and give you some hints on how to write stuff. And that was installed for me automatically, while that was not part of my extensions normally. So what you can do, like probably in the situation of a open source maintainer, you can create this dev container with extensions that come in very handy whenever you start working on this repository. And you can basically push that to your contributors on top of the extensions that they have already installed. And you will just get that and get to use it. And that was a nice surprise when I was working on that. So that's pretty cool. So you can specify the extensions that will be installed on this Codespace whenever a user creates a Codespace from this repository. Here are some more things that I don't really understand at this time. And here you can set the forward ports. So these are the port forwarding things that I just mentioned, right? Like those are forwarded to the local host of this Codespace machine. So you can add them here, so you don't have to add them manually each time. You can just add them here for all the services that you need, and those will be open automatically for you to use whenever you spin up this thing. Here is a bit of settings. So this is the setting specific to VS Code. So you can set like, okay, I want to have my default shell should be bash, or you can set like your font that you want to use in VS Code to the nice font from Microsoft, Cascadia Code or something is it called. You can do all those kinds of things, do all the settings in VS Code basically from here. So then if we look very quickly, I'm not a Docker expert. We're going to learn all of that in the next session, but you can compose a Docker file here and you can say, okay, I want this locked to a certain .NET Core version. I want to set up a specific username. I want to install Node. I want to do something with my environment variables. I don't even know what half of this stuff means. I know the words, I know Azure. Seems to mean something, but so you can compose your Docker file and your container will be spun up exactly according to this Docker file. So that's pretty cool. So in case you were wondering, I already mentioned it. Like here is the actual VS Code client that's running on my Mac, and I here have that same Remote Explorer thing. So you can see this is the .NET Format one because I already started it early. But if I refresh now, you can see that I can access this one as well. For the fun of it, let's just do the .NET Format one. Let's connect to that. Hopefully the demo gods will be with me because I did not rehearse any of this basically, but certainly not this one. So we can see this was suspended. So this was like dormant somewhere, sleeping, waiting for someone to wake him up. And that's what I'm doing now. So I don't know if someone started the stopwatch, but this should be working in like 30 seconds, 1 minute maybe. So maybe it's a good time to check if there's any questions. And there are. Oh, there are. Questions.
So I've been filtering through them. There is one here asking about the experience and the bandwidth requirements in terms of internet, especially if you're using the browser version.
Right. So I see Matthew already pointed you to somewhere in the documentation. I think it's not too bad. I think I saw this question come up somewhere through Twitter as well. But I think that the bottleneck there was like more like that you would still. I mean, it's less than an actual developer machine, but you would the bottleneck would sooner be the amount of RAM that you would need to run this thing in a browser or whatever than the actual bandwidth. So it's like only pieces of text that are sent back and forth right now. So whenever you go to the scenario where we are actually starting to mirror desktops for showing Xamarin apps and that kind of stuff. So we're actually like streaming the remote desktop things. Then yeah, the bandwidth should go up. But as long as you're doing like web stuff and terminal-based stuff, then it shouldn't be that big. Will there be a Xamarin demo? No, there will not. I'm sorry. I was going to try over Xamarin into my function stock. Every demo should have Xamarin. Yes, that's definitely true. I'm going to work on that. But the demo gods are not treating me nicely because this is not seeming to resume very nicely.
I've got one question if we want to wait a little longer. So it all looks very cool. And you mentioned someone asked a question before about Xamarin support in Maui. So what do we get out of the box when we spin up a brand new Codespaces? Sort of the default supported tech.
That's a good question. I think there is documentation on that somewhere as well. I think when you're doing the default thing, actually I should try to find that because I'm not entirely sure. That's the. I think there's some documentation here. Let's see if we can quickly find it while we're waiting. So I would expect that there is, it's Microsoft stuff, but although it's GitHub now, so I would expect to have some .NET Core support out of the box. To be honest, I'm not entirely sure, but I will find out and I will get back to you. I'm just not entirely sure at this point. That's the downside of just working on getting it to work and not actually working with it. I'll find out. I'll let you know. I'll follow up.
Yeah, that's cool.
All right. Yeah, I'm going to go back. I'm just going to skip this one because this was too wild for today. This is not going to work. So in any case, if I, whoops, you did not see this. I actually dropped my mouse. I'm getting nervous of stuff not working. Okay, there we go. So can I get a new window? And just connect to the other one. That should just work. because that one's already there. Oh, and now the other one is finished, right? Yeah, of course. No, this is the .NET Web one. Okay. Oh, this is interesting. So now both started to work. Well, normally that should be much, much faster. I'm not sure what's happening here. But so it would be no surprise that all the things that we've just seen in the browser, you can do that here as well. So here I have it's the other one. So this is a GitHub action that I actually started working on. And you have all the same things, file, all the same support things. And now I can just go into a terminal right here, and this one also has npm installed, so I can just say npm all the things, download the whole internet, and it can do that as well. So one last thing, I add a little Xamarin to the demo, so let me just do that really quickly. And then I have a couple slides and we'll be done. So actually to do a couple of things, I also have what is it? I was working on a new website before all the things in the world started to go wrong for the Exam Expert Day, or the Expert Day for Xamarin, which is a name I always hated. So note this is a private repository, so this is something that is not out there because, to be very honest, I think it has some hard-coded Azure credentials from me, so this should never see the light of day. But I was working on this, and just let's see if we can make this work on the Windows side of things. So I'm going to magically switch over here to my Windows machine and see if I can guess my password. So this is Visual Studio 2019. If you've been watching Ignite, then you probably have seen this a little bit as well. There is a new button here in my special version, which says connect to a Codespace. And if I click that, it's going to connect to GitHub as well. And I have this from a previous demo, but you will not see the other one. So because this is a Windows one, right? So I'm not going to see the Linux one here because that is not supported yet. Who knows what might happen in the future? And I can also create a new one here. So I'm just going to add my repository here, and here you can see. In the future, this will also be a thing for the Linux machines, but here you can see like, hey, what kind of VM you want to spin up, right? So 4 cores, 8 GB, 8 cores, 16 GB, and that will also be where the pricing difference is, right? Yeah, you can do more cores, less cores, more gigabytes, whatever. So let's just go with a standard one, and here also is like the suspend thing, so this ranges from 5 minutes to 2 hours. And I could just click create a connect. So it will go through a couple of things. It will get my GitHub credentials, of course. It already has them. Clone that repository, and yeah, it should be up and running again in not that much of time. And the cool thing about this is if you go to, I'm not sure if I can show that actually. If you go to like the Visual Studio installer, you will now have a workload that just says Codespaces. So you can now just install this, all the updates, all the versions. Can I modify? Does that bring up the thing that I want to do? So you can have all these workspaces. Oh, here we go, all the workloads. And here we have like the Visual Studio Codespaces one, right? So if that's what you need, you can now just skip all of these above here. You can just uncheck them all, and you can just do Codespaces. You can install the like full Visual Studio 2019 in 2 minutes or something with that, because it will just install like the basic editor and things. And you can clone your Codespace in another minute. So you can be up and running with Visual Studio 2019 with all the extensions and everything that you're used to in under 5 minutes. So that's very cool. So you can see this went a bit more fortunate than my other unexpected demo. And here it cloned like my Exam Expert Day website, so I can open the solution and it will switch the thing here. And this is just another ASP.NET something project. So this is not responding. Also, as you would expect from Visual Studio 2019. And so you have your project here. I can start start doing all my things here. I can, well, while I'm being wild, I'll just see if this runs. So it starts building, and it will do anything that you will expect it to do. So you can see by this little icon here that it's a Codespace thing and nothing else. But all the rest will just work as you would expect. Oh, is this recorded? There were my credentials. No. Okay, so that's wild enough for one day. Let's see if there's some more slides. So what have we just seen? A fully featured development environment in the cloud. It's pretty lightweight, pretty fast. Very light on the broadband connection, on the bandwidth. It's all powered mainly by VS Code, so you can run that from the browser, from the actual VS Code. You can do the full Visual Studio 2019 experience. There might be other clients, I don't know, in the future, or other ways to do this. Who knows? But you can use the built-in debugger and runner just like you would expect to do from something that's locally. So there's the automatic Git configuration and your GitHub login, because it's all initiated by GitHub right now. So that's all set up for you, no problem. It's just a seamless experience, and you can get started with that. There's personalization through like the dot files and the dot containers, so you can do like the real personalization on your terminal and your fonts and your dark theme, or through the dev container for like the whole dev environment a little bit more globally, and probably some other things that I'm forgetting right now, like the awesome port forwarding stuff and my failing demo. So the best is yet to come with the questions that are asked. Well, that's unexpected. You can sign up at the link that I just showed you a couple of times. And like I mentioned, it's free in a preview. There is some pricing info available right now, which is only for the Linux bits, I think. So for the Windows things, I think they're still figuring it out. That's above my pay grade, so I don't know. But they will come up with something. You can have multiple different machine configurations, so not just for like the Windows things. You can have the different specs that we just saw. That will also become available for Linux. And also, one thing that is probably to be expected is like the more GPU heavy machines, if you're going to do more AI stuff, which is I think a pretty ideal solution. So you don't want to set your machine on fire locally. You can just set a machine on fire in the data center. So you will have GPU machines available as well for those kinds of solutions. So there will probably be more scenarios that they will come up with, different workloads that you want to run on these machines, and there will be different machines to support that as well. There will be coming full support for organizations. That is GitHub organizations, and that also hooks back into the billing side of things. So billing will happen through the organizations as well. Desktop app support. So again, that's going to be something with mirroring UI stuff. That's coming. I can't promise when, because I simply don't know. But I mean, of course, that is something that's coming, because from our history at Microsoft, we like to run our desktop apps, right? So WinForms app support is definitely coming, and probably much more. So find the Ignite sessions for the very latest info that was just released, because there's a lot of awesome sessions in there, probably a little bit more specific to certain features that I've showed you today. Here's where you can learn more if you were interested in some of the bits. It's not a very interesting repository, but you can find that right here if you want to take a look at like the dev container for some inspiration, if you get your hands into the preview and you want to get started. There is some docs, so again, please look into that. I'm pretty sure there is some list somewhere with the default software and SDKs that are installed. So please find that. I will do that as well, and hopefully put that in the chat in a little bit. All the information and sign up at the link that I already mentioned before a couple of times. And then there's only one thing left, and it is to thank you, all of you in the organization, for having me, and all the attendees watching me.
Great, that was fantastic. And I just wanted to point out, failed demos show that they're real demos. So kudos to that you actually did live demos.
And I'm an actual human too. Yes, I hate to admit.
Exactly. Yeah, that was all very cool stuff. And I guess my biggest takeaway from this is that finally I don't have to deal with the node modules folder on my machine. I can just have it in the cloud.
Right? Just save it somewhere where you don't have to see
it. Yeah. Don't break my Windows file directory. Okay, so up next is Quentin. And while he's busy sharing his screen and getting ready to present, I'll just do a quick intro. And I'm going to preface this with, I stole this straight off Twitter. So the last piece I'll just leave without context, and Quentin can go straight into his session. So Quentin's a lead system architect, full stack polyglot developer, IT infrastructure architect, Apple slave, and teacher to Google. He can explain that if he wants to. Over to you, Quentin.
Great, yeah, that's something that's been on my Twitter bio for a long time, and I think for me, I've fine-tuned the Google search results so well looking for code examples. So that's where the teacher part comes in, for teaching the AI and algorithms behind the scenes there. But yeah, thanks very much for having me. Quentin Barnard. I work for a company called README.md Software based here in Cape Town. I've recently moved on to technical director, being my official title, but I'm still very much a software developer at heart. And yeah, love development and technology and all these great things. And one of those that's close to my heart that I've been sort of punting for a long time is Docker. And I thought to share that with the community tonight as well, just sort of go through what Docker is, what it can do, and how it can make your life easier. And as you've seen in the previous session, Docker is already being deployed in Codespaces. So I think this is a great segue to that, to follow on in terms of what you yourself can do with Docker and how you can use that to make your life a lot easier. Cool. Ooh. That wasn't meant to happen. That went straight to the end. Let's try that again. If my screen comes right. There we go. Alrighty, so in terms of Docker and actually understanding where it fits into the ecosystem in today's technology, I thought we start off with a little bit of a trip down memory lane, just to sort of see, having a look at what's happened in the tech space in the last couple of years and how we've ended up in the environment of Docker. So I'm going to touch briefly around physical machines and the role that they've played and how we've migrated from physical machines to virtual machines, and then getting into containers and how containers has made life significantly easier in today's DevOps and tech space. Starting off with the physical machines, I'm quite sure a lot of you sort of, obviously wonder what data centers look like and sort of what all runs in them. And as you can see from the picture here, data centers are, sometimes messy, lots of servers happening there. It takes up a huge amount of space. Obviously, lots of heat generated from there. And in the South African space, I'm quite sure you're all familiar with the data centers that pop up in South Africa with all the major cloud providers now, in Cape Town especially. So bringing our data right to close to our shores here. But the problem with physical machines and the data center environments is it's a costly exercise to get that up and running. So if we look at the traditional sort of corporate space, you'll see that corporates have their own sort of data center that they're running. Setting that up and making sure that fire retardant systems are there, and you've got sprinkler systems and all sorts of things. It's a very costly exercise to get all of that up and running. We're also having a look at things like operating systems and preparing physical machines. So, in the old days, you wanted to deploy your application, you would go through the process of acquiring a physical server that would need to get installed. Then you would go through the operating system installation process. And once you've gone through that, if you've survived the RAID drivers configuration on service, I don't know if any of you have had the pleasure of dealing with that pain, but it's certainly not something that you want to do. It's some of them, I don't know about today, but in the past, the RAID drivers would come on a stiffy disk that you had to pop in at some point during the installation, and hopefully you timed it right, you'd get your actual hard drives operating on your machine. But of course, one of the other downsides with the servers and the big infrastructure that they take is obviously the space that they take. There's the power consumption considerations that you need to take into account as well. And when you get to things like scaling up your applications, this is now where things start getting difficult. because now you've got your fancy new MVC, ASP.NET app running there, and now you need a second instance of it because the first one's not coping. Now things start getting a little bit tricky because now you need to start getting networking teams involved. You need to get load balancers and hardware load balancers, etc., etc. So I'm quite sure you can sort of see why it becomes quite difficult and cumbersome to run physical infrastructure. A couple of years ago came the virtualization space. We had VMware and Microsoft Hyper-V come into the space, the Citrix Zen server. I'm surprised it's still around. I haven't looked at it myself for a long time, but great virtualization platforms. And the benefits that brought to the greater scheme of things is that you no longer needed to spin up multiple physical machines to create instances of your applications. You could create one physical server, and on top of that, you could create virtual servers that basically ran on top of the existing infrastructure that you had. The benefits of this is you no longer needed to install 10 physical servers in your rack for 10 applications. You could now go, one physical server and run 10 instances of that operating system on top of that physical hardware. The problem with that, however, though, is the operating system itself obviously takes a lot of installation and maintenance and requirements. As well as that the footprint of the operating system is quite big. So again, if you look at Windows and installing Windows Server, it's obviously come a long way in the recent years, but if you're going back to sort of Server 2013 and back in those days, you looked at a 20, 30, sometimes 50 gigs operating system installation alone. So you can imagine if you had 10 applications that you need to spin up in 10 instances, you're already looking at half a terabyte of just disk storage for the operating systems that you needed. Along came Docker, and what that has done is it's just made the world significantly easier. So the concept at the end of the day is still very similar, where you've got a physical machine that really runs at the base of it. You've got an operating system that runs on top of that. And now you've got the actual container orchestration or the container platform that runs on top of that again. The benefits here is that what Docker essentially does is it virtualizes the operating system for you. So instead, in the past, where we looked at virtual machines, it would virtualize the memory and the CPU and the disks, etc. Now you actually just have one operating system that is virtualized for you, and it allows you to spin up your platform significantly faster. So you can run Docker containers on Linux platform. You can run them on Windows and on Mac OS. I'm running on Mac, so we'll do. Hopefully the demo gods are with me, and we can get through the demos tonight on this as well. But yeah, you can absolutely spin these up on your Windows environment as well. So if we just take a little bit of a closer look in terms of how the actual server or virtualization environment is structured, you can see that it's based on different layers. At the bottom of it, we've got the physical layer that's running there. Then you have the actual host operating system that's on top of that. You've got the hypervisor. And you'll see on the left-hand side of this drawing is where we've got the guest operating systems. So this would have been the operating systems back in the day. So give me 1 sec.
Dad, instead of pushing one time, it makes me have to push like 1,500 times. Can you open the battery up and change?
Kids, eh? This is one of those BBC moments.
Can I have this?
Yes, my love. All right. Cool. Anyway. Carrying on here. So getting back to the way that the actual virtualization takes place is we've got the physical servers, we've got the host operating system, the guest operating system, which is now currently running in the virtual machines. And then you actually really have your application that sits right on the top of that. If we look at the right-hand side of the screen, you can see the distinct difference between the two. So the foundations is very similar. So you've got the physical server with the host operating system. Instead of a hypervisor, you now got the container engine, and your application basically lives on top of that. So you can see that we're significantly closer to the actual bare metal than what we would have been in the virtualized or the virtualized environments. Looking at different options for running containers. So Docker is not the only container platform out there. There's CoreOS that comes into it, Containerd, there's Rocket as well. So those operating systems or sort of containerization platforms are available for you to spin up your applications and make them operate from there. I'm not going to run through the process of actually installing Docker. It is if you go onto the Docker page and they've got Get Started, the documentation is actually really good, and there's lots of useful information around getting started with Docker. Alrighty, running off to our first Docker demo. So I trust that you can see my terminal here. So basically what I'm going to do is I'm going to spin up a Linux operating system.
Sorry,
and
we can't see, we can still see your slides, not your terminal yet.
All right, give me 1 sec. Let's see, try that again. I'm going to just reshare. Let's try that. Okay, can you see the terminal now?
There we go. Yes, we can.
All righty. So the Linux operating system that I'm going to spin up is called Alpine. It is a really lightweight version of Linux, stripped down with all the guts, and it basically gets everything up and running for you. So the short version of that is basically just enter the Docker command. So saying the documentation for Docker and how to get up and running with it is well documented on the website. But the short version is you do Docker run and you specify the actual name of the container that you want to run. So I'm just going to do Docker run Alpine. I'm going to hit enter on that, and then what happens behind the scenes? Docker run. We're going to go interactive. And what it will do is, if you don't have the Alpine image on your local machine already, it will pull it down from Docker Hub. So if you go to hub.docker.com, is where you can see a list of sort of predefined and public available images that you can use to spin up the containers. So if I spin it up here, and you'll see within a couple of seconds, now I'm sitting at the actual terminal window, and as you can see, this is a normal Linux machine that's running here. I can exit out of this, and it'll take me back to my terminal window. Out of interest, if we go and have a look, so you can run a command called docker images, and what that will do is it'll give you the list of the images that you have on your local machine. And if we scroll up here and we're having a look at, just find Alpine in the list here. Maybe I've gone a bit far. No. It's not jumping out at me here right now. There it is there. So you can see that is the actual image that's been run, and you can see that was only 5.5 megabytes of actual disk space that was used pulling that image down. So compared to traditional operating systems installations where you would run a 20 or 30 or 50 gig installation, you can now see the significant savings that you have in terms of being able to spin up multiple images or multiple servers of your instances of your applications without saturating all of your disk space. So yeah, I mean, we mentioned that obviously Docker runs on Linux as well, but don't fear, they support, or you can pretty much run almost anything inside of Docker these days. Of course, from a C#.NET environment, you can spin up your APIs inside of that. You can spin up worker services with .NET Core 3.1, but it's also the older versions of .NET Core is supported there as well. You can spin up Ruby apps, Go apps. There's Node.js if you really wanted to as well, PHP, Python, etc., etc. They are all supported in terms of actually running them inside of Docker. One of the things where it gets a little bit tricky is some of the old technologies like WCF and WPF in the cross-platform environments like Linux. That is rather tricky to spin up and get up and running. But there are options for this to run Docker on your Windows environment, where it actually uses Hyper-V as the container orchestration layer that sits underneath that, and that allows you to run some more traditional Windows-based applications. All right, I'm going to skip the slides, introduction to .NET Core. I'm quite sure you're all familiar with .NET Core by now. It's been around for a couple of years. But what we'll take a quick look at is actually spinning up a Docker container with a .NET Core API inside it. So basically, the application itself is just the standard web API that you create from scratch. So if you go .NET new web API, it basically spins up a working API for you. And we'll have a look at how you actually package that into a Docker image. And in order to do that, you build up a Docker file that basically resides on disk. You give it a couple of instructions. So as you saw in the previous demo as well, you specify the image that you want to use as your base image. In this case, I'm going to use ASP.NET Core, where I'm going to say what is the working directory that my application is going to reside within. So this would be your sort of standard program files, etc. in the traditional Windows space. We're going to give it an instruction to say what application do we want to put inside of this. And in this case, we're going to say there's a copy command And we're going to copy the contents from this bin debug netcore app publish directory into the container. So this path is relative to where this Docker file is actually running. Then a little nifty trick for those of you that may not know, or it will catch you later on in life, is that the time zone is because you're running essentially a operating system from scratch. It defaults to GMT. So in the South African space, we are obviously GMT +2, and you might wonder sometimes when you're looking at logs and outputs from the container that it's actually 2 hours behind. And the catch to that is to actually just set the time zone in the container. So as a default, that is what I'm doing here. I'm specifying an environment variable to the Linux operating system that specifies my time zone as Africa Johannesburg. Down the bottom, we've got the environment variable that we're establishing as well. Here is the port number that we're exposing for our web API. And as I'm quite sure you know by now that the default port 5000 for .NET Core apps. The important part at the bottom here is the entry point. This tells Docker what application to run, or essentially what command to run when this container starts up. So in this case, we're specifying the .NET command, and we're specifying the actual app that we wanted to run. So this is basically the same thing as if you create a new web API or a new .NET app. From the actual CLI, you can go .NET run, and you can specify application, and your application will actually spin up. So that's basically what Docker is doing under the covers for us. Just something to note, the traditional naming convention for a Docker file is, as you see it here, it is just Docker file. There is no file extension associated to it, but you can, of course, basically use any file that you put into the right format, and you can tell Docker to spin that file up by actually specifying the file name. Alrighty, let's see if we can get this second one going here. Let me just get the right window. All right. So what I have here is just, as I said, it's a straightforward web API. So from here, if everything goes well, we'll be able to go .NET run, and this should spin up the application. Interestingly enough, while we wait for this to spin up, this is actually running .NET Core 2. I was going through the prep for this demo earlier today and discovered that I actually did these demos quite some time ago. So I'm quite impressed that even in 2020, .NET Core 2 stuff still actually runs quite successfully. Hopefully, this is taking slightly longer than it should. But as I say, from the CLI, you can just do .NET run. You'll see that my actual demo app, CS_proj, sits inside of the same directory. And you can see some stuff happening in the background. Come on. And we get the application up and running. Now, so there we go. That took long enough. So you'll see the actual application spun up. It's running at localhost 5000. And if we jump over to the browser, we should now be able to call our API. There we go. So you can see that we've now actually loaded up the API. It's running at port 5000. So that's running on our local machine. But this is sort of pointless now when you get to a deployment scenario. So ideally what you want to do is you want to be able to wrap this in a Docker container, and you want to be able to package it so that you can deploy it into your actual applications. So give me a sec. Let's just get to the right directory here. Oops, yeah, it helps. All right, type the right commands. Let's get it here. Where are we? So just one moment. I'm going to have to get somebody to cue some elevator music while we get this loading here.
Dun, 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 dun. That's the best I've got.
That's pretty sad.
Alrighty, let's try this one. We should have it here. Let's open up a new terminal window. Alrighty, so here we've got the same application that we had earlier. The only difference here now, we have the actual Docker file in our directory. So we're going to go cat Docker file, just so you can see what the output of that is. You'll see, so as the slide showed earlier on, we're loading this we're using the base ASP.NET Core image. We're setting our working directory. We are telling it to load our application from publish, which is our output directory, and then we're basically spinning it up. So to get this up and running, you basically run docker build. You give it a -t, a tag. So this is what we're going to call this application, and we're going to call this, just say demo app. And we just specify a full stop at the end. That full stop is where you would normally specify the actual Docker file, and because it's in the existing directory, it will pick it up automatically. So if we now hit run, so what Docker is going to do is spin up in the background. We'll quickly run through this here. So step 1, you'll see it shows step 1 of 5. It would have pulled down that base image if you didn't have it already. In my case, it's using a cached version. It is then copying the actual application into the working directory, setting our time zone, setting the entry point, and it says, great, we are done with what we needed to do. So now if we're going to run Docker images, our application is now actually packaged in the Docker file, the Docker image, and you'll see there's demo app there. And in order to run this now, so if we go Docker run, and instead of pulling it down from the remote site, we actually just pull it up on our local dev machine. And hopefully this starts up a little bit faster. There we go. So now we can see that it's running. Our local host 5000 has disappeared. But now if we go back to our browser and we run this, oh no, let's try this one. No. Alrighty, let's check. We've got port 5000. It should really be picking it up on this URL right now. Maybe we'll get back to that one. What was that about failed demos?
Failed demos are real demos, so we appreciate you taking the risk.
Great. All right, so yeah, but essentially that's how easy it is to really package your application inside of a Docker container. All right, so there we can, so one of the things that we can do, I'm quite sure you're all familiar with the, oh, but it works on my machine scenario when we're getting into deployments. That is generally a result of you know, in your dev environment, you might have a specific library that's running there or specific configuration. And of course, when you spin up the application, it just works with that specific setup. So one way to get around that is we can do a little bit of cheating and we can build our application in a clean environment. So here we use a Docker file as well, but we use what is called a multi-stage build. What we do with that is that we use a Docker file to actually install the SDKs into. So you'll see on line 1 there that we've got the .NET 2 SDK that we're pushing into a container that we're calling build. And what we do with that is that we use that to then basically create our clean build environment. We copy our source in, so that is the copy source that we're doing at the bottom there. And once we've actually copied the source into our application or into the actual image, we run the .NET build command that you're seeing there. What will happen there is that the actual build will take place. Obviously, assuming everything is successful, you will then get your actual your output, your actual exe, your application will get generated into the output directory from there. Then what we do is we then alias. You'll see at the bottom half of the screen where we've got the runtime. We then basically copy the artifacts that we built in the top half into the container in the bottom half. What this allows us to then do, as I said in step 1, is it gives us a brand spanking new clean build environment that we pull into that. We then copy the actual artifacts out of that into the new image, and then we basically just run it like we ran it before. So that way you can ensure that when you're saying it works on my machine, that it actually does work on every other environment that you run. Keeping in mind the benefits of platforms like Docker is that it allows you that mutability or that consistency across the different environments. So if you're working on a Windows machine with Docker or on a Mac or on a Linux machine, or you move it into the cloud, the infrastructure or the actual platform that it virtualizes for you is consistent. So that allows you to get away with it, that it actually works on my machine. All right, let's see if we can get through this one. Multi-stage builds. So basically what we have is the same application. We have the similar Docker file that we set up earlier, but you can see there's two components to this Docker file. So the first one is where we're actually building the container like we did before. For that, of course, you need the SDK, the actual software development kit, because we are going to be building the actual application from source. And then the second one is where we're actually building the container that hosts our application. So let's try this. We're going to go docker build -t testing2, and we're going to specify the local file. You can see it running through. So the first one, I've pulled these containers down, or these base images onto my machine already. So that's why it's nice and fast. You'll see we're now hitting the actual build process. You'll see the Microsoft .NET Core compiler running in the background there. I'm actually just having a look, because earlier on, yeah, it's happened again. That's why my machine's so slow. Max decided to run a backup in between. That's why it's taking a long time. Let's see if we can skip that a second time.
You should try Windows.
Yeah, talking about that.
Should have been using a Codespace, man.
Yeah, exactly. That's where that comes in handy. So yeah, this is unfortunately going to take a little bit longer than anticipated. Hopefully this will stop in the meantime. But you can see the actual build process carrying on in the background. So again, to sort of summarize, is that from the working directory that I'm in, my source code was copied into the container. We're using the actual SDK version, so we're able to compile. You'll see there's the compile output. A nice clean build, no warnings and errors, so that's successful. And then there we've just completed the second step now. So the artifacts that we've built in the first step has been copied into the second part of the container, and it's now actually built our actual container that we can then run. I don't know if I'm going to attempt running this a second time. We'll try one of the other ones a little bit later as we go through this. All right. But of course, your application never lives alone. So often we have applications that are dependent on databases. We've got applications that are dependent on web servers and all sorts of other paraphernalia. We might have caching, so you might have a Redis instance that you want to run as well. So what we can do is to basically pull all of these things together. Is we can use what is called a compose file. A compose file allows us to actually compose the environment that we want to spin up. And with that, we can basically link a whole lot of dependencies that we want to run. So in this example here, we're going to basically spin up a Nginx proxy server that we're going to run in front of our actual web API. We're going to set up a dependency between the two to make sure that Nginx is aware of the actual API that sits behind that. And hopefully we should then get to our API. So this is a quick example of what the compose file looks like. You'll see the version number that you specify at the top. So this is, of course, all composed in YAML. You specify the services that you have. And at the top here, we're giving it a name of Nginx proxy. We're specifying the image that we want to run from, which is Nginx latest. So this will get pulled off Docker Hub. We're giving it a name, in this case, Nginx. What we're also doing here is we're mounting volumes from the local operating system into the actual container itself. So that's the first half that we're doing here. We're specifying the local config file separated by colon. That tells us where this file is going to be mounted inside of the actual container. And at the end here, we can tell it whether it's read-only or read-write, etc. So this is quite handy specifically for web-type applications where you don't want the web application to write to disk. We can actually make that volume mount into the container read-only. Similar to what we're doing at the bottom is we've got static applications. So this is one of my sort of techniques that I like to do. So if I'm building a single-page app like React or Angular, etc., I then actually use Nginx to serve that application as well, and we can mount that into the actual directories. And of course, with SSL certificates, etc., you can copy that into the container as well. What we're doing at the bottom is we're exposing the ports. So keeping in mind in our API, we ran on port 5000. That's probably why I couldn't get to it, because I spun up the container without exposing the ports. But in the actual compose file, we're specifying what those are. And here you can see where we're now specifying our dependency. And we're saying that this Nginx application has a dependency on demo app. And then from the bottom, we can see this is now where we're defining demo app. We are specifying what image we're using. In this case, we're using demo app, the container name, as well as the ports that we then want to expose for that specific application. And from a networking perspective, this links at the bottom here allows us to, so what Docker does is it will create a virtual network that will allow these two applications running in two separate containers. It will allow them to talk to each other. All right, let's see if we can get this one up and running. So again, what we have here is we've got our SSL certificates directory that we're exposing. Here's our actual compose file that we've built up. So you'll see it looks very similar to the one that we ran earlier. The only difference here is I'm specifying port 8080 to make sure that it actually works on my local machine. We have the HTML content that I want to load into that, and then we've got the actual Nginx configuration that we're using here. So that Nginx configuration just tells Nginx where this application sits behind the scenes. So if we now go, so the command is a little different. So for Docker specific commands, you will use Docker, but the companion application to that is Docker Compose. So we're going to go Docker Compose up. And what we're going to do here is we're not going to specify a file name. By default, it will automatically load up your actual Docker Compose YAML file that you have in your local directory. If we spin that up now, we should see the output. There we go. So it's creating Nginx. And there we go. So if we just look through this, you can see our Nginx proxy has started up, as well as our demo application. And then here we can see the output from that actual container. It's showing us our hosting environment is production and our application is running inside of app. And you'll remember from the previous, when we specified our Docker file, we said that our application actually runs inside of the app directory. So if we come back to here, so localhost API values on port 80, we should, there we go, success. So you can see that the local host has now hit our Nginx proxy and it's now actually pulled the content out from our actual web API that we're running inside of our container. And just if we shut that down, so Control-C, what Control-C does, as I said, it stops the process. It also tears down that environment that we built up. And if we hit this now, it should be non-functioning. So that is an expected result. What you can do as well is you can run this in the background. So this is where you get to your production type environments. You can go Docker Compose up with a -D at the end of it. And that basically spins that entire environment up in the background. You get your terminal session back again. And if we jump back here, we should hopefully get the same output again. There we go, up and running. How do we know that these things are actually running, that I'm not pulling the wool over your eyes? We can do a Docker PS. What Docker PS does, it says show me my running containers. And if we just make this a little bit easier to view, you'll see there's our two containers that we're running. So the top one is Nginx. You can see that it's bound to our local host. We're exposing port 80 on it, and there's our name. And here is our .NET Web API that we're actually running underneath that. So you'll see it's been up for 19 seconds. And you'll see there's our actual .NET command that we're running. So that's similar to what we did earlier in the terminal, where we just did a .NET run. And there we go. There's our two applications running in the background. So now the tricky part with this is you've built it. Now you need to get it out into the production environment. How do we do that? It is actually quite easy. There's two ways of really doing it. The recommended way is to use a Docker registry. But there's also a manual way that you can actually deploy these containers if you really wanted to. So the best way to do this is if you've got access to Azure and Azure portal, you can actually open or sign up for a Docker registry on there. It is actually really dirt cheap. It works out to about, I think, about 60 Rand a month, and that gives you, I think, 10 gigabytes of storage in the actual Azure registry itself. Yeah, so let's have a look at that. How do we get that up and running? So again, if we go to see if I've got my Docker file, let me just go back to the one where we had the Docker file. Give me a sec here. Okay, this one here. So we can take our actual application that we have here. So there's our Docker file. So similar to where we ran the Docker build earlier, we're going to you're going to run another Docker command, which is the -t for tag. You're going to specify the container registry that you want to run it to. If you give me a sec, I'm just going to check what this one is. I can't remember offhand. There we go. Here's my one here. Alrighty, so before we do that, let's just have a look at our images that we built. Images. And you'll see, remember that we ran, so there's test 5 and testing, etc. So those are the containers that we built. So we'll use the testing one in this example. We're going to go, Docker tag. We're going to specify the tag that we want to take. In this case, this is the name of our container registry. This is, as you see, it's got Azure CR, which is the Azure Container Registry. You're going to give it the actual image name, and you're going to give it the image that is actually on your local machine. If I spell that correctly, testing. All right, now if we rerun our Docker images, you'll see that right at the top of this, there is our Docker testing should be in here. We'll just grab the one that we did earlier, which is that one there. So all that this basically does is it takes the image that we built earlier, and we're just assigning a new tag to it. In order to now get this actually into your registry, again, very simple, we're going to go Docker push. I've already logged into this registry, so it's pretty straightforward. You specify the name that you want, and you just tell it, great, take this image and shove it into the registry on the other side. You'll see what's happening here is that there's a couple of layers that are built. So these layers essentially is diff files between the base image that we started with, so the ASP.NET Core, and these are the changes that we've made to it. For every change that we make, Docker creates a new layer. So in other words, we ran 5 or 6 or 7 different steps. So we copied our source in, or we copied our artifacts in, we set the time zone, we specified what the working directory was. And for each of those, Docker will create a snapshot, and it will basically create a layer that it then uses to reassemble that image on the other side. In terms of now on your production machine to run this, it's basically exactly what we had earlier. You're just going to go Docker run, and you're going to specify the actual tag that we used. And if all works well, it should pull this down. There we go. There's our web app back up and running. Great. So what we've done now is we packaged the application. We've tagged it with a Docker registry ID, which you get from, in this case, Azure Container Registry. We've pushed it into that, and on the other side, we basically said, run this container for me, and it's pulled it down and spun it up in our actual environment. All right. There's a couple of interesting things. Some of the more technical side of Docker is around networking. As I mentioned, by using the links is the sort of shortcut to get it to link your containers and get them to work and connect to each other. But you've got fine-grained control around this as well. So we had a look at linking containers. By default, Docker will spin up a DHCP server for you, so your application will get an IP address from the actual DHCP server that it provides. You can also specify static IP addresses. You can create your own networks. And as we saw as well, you can go and specify what ports you want to expose through your application. And a quick look at how you do that. So again, looking at our compose file that we had earlier, we had Nginx with the volumes, etc. You'll see at the bottom, there's a new section here, networks and Nginx. What we're doing is we're creating 2 networks. There's a public network, which is the one that would be internet facing. And then we create essentially a private network that sits behind that, which in this case is called internal. And you'll see here that I'm manually specifying IPv4 IP addresses for this Nginx instance. It will essentially get 2 network cards at a high level, and those network cards will get these IP addresses. And then down the bottom here, you can see where we're actually defining what the structure of that network is. So in this case, we're setting up a bridge network. We're specifying what the range of IP addresses are for our public network, and then at the bottom we're specifying our internal one as well. But this is sort of where things start getting a little bit hairy and a little bit tricky in terms of actually the fine-grained control that you can have over Docker and specifying how to spin up your environment. And then sort of getting towards the end of our conversation here, obviously one of the big things nowadays is Kubernetes in terms of actually scaling up your application. So Kubernetes is fantastic, coupled with Docker Swarm as well. So you can actually run this on your local machine. So you can go and say, for my API, create me 100 instances of this API, and Docker will go off, or Kubernetes in this case will actually go off and spin all of that up for you. There's all sorts of wonderful tools that sit behind this. So there's things like load balancing and service discovery and auto recovery. So if you have a container that crashes perhaps, Kubernetes will take care of actually spinning that up for you in either the same data center or across data centers. But that is a very technical topic for another day. And that's me. Not sure if there's any questions. Happy to answer those.
That was great. I really enjoyed that you took us sort of from the beginning to the end, showing us how to build stuff up and actually getting it deployed. I've got one question. Containers as a whole can be overwhelming. Do you have any suggestions on some good content or where to start, sort of just like as practice or playground to learn Docker specifically?
Yeah, so there's a wealth of information of containers as a whole on the internet. So a good place to start would be YouTube. There's literally a ton of videos that you can go and watch that takes you into, again, some of the basics, how to get started with it. And if you're a .NET developer, as you could see here, I mean, it was pretty straightforward taking an actual application and wrapping that into a container as well. The Docker documentation is also very, very good. It explains a lot of the topics in detail as well, with all the different switches and flags and things that you can specify. In this demo, we've barely just scratched the surface of what you can do. And same for Docker Compose. So the Docker Compose documentation is also really, really good. So yeah, please, so docker.com. You can go and check that out, and there's a wealth of information around getting started with Docker.
Yeah, I think that's it. While you were presenting, I've gotten some feedback on my end about my elevator music, so I'll just like to apologize for that. I'm sorry for spoiling your demo.
We'll put that one over to Apple doing a backup in the middle there.
Yeah. So I guess in the meantime, as Dustin is getting ready, I'll do a quick intro. So next up, we've got Dustin, and he's going to be chatting to us about serverless, specifically with Azure Functions. And Dustin started coding at the young age of 8, which is impressive, and hasn't stopped since. He loves designing and building software solutions and has done so for the last 2 decades. He really appreciates something that's simple and elegant. And over the years, he's gone through all the different architectural patterns, obviously microservices, and more recently, he's been looking or going through the serverless revolution. And has spent the last 5 years designing and building cloud mobile solutions, specializing in Azure serverless and PaaS capabilities, as well as playing around with mobile and Xamarin. You'll often find him on local user groups like this one, talking about technologies that he has a great passion for. Over to you, Dustin.
Wow, Pravindran, thanks for that. Where did you get that mouthful? I don't know. I didn't realize you were going to use all of it. Yeah, thanks very much. So, thanks very much, everyone, for sticking around till the late session this evening. I'm really excited to talk about stateful serverless, which is something I'm pretty passionate about. So without further ado, I'm going to share my desktop so we can get going. So someone earlier asked for if we can have a Xamarin demo. This is about the closest you're going to get to a Xamarin demo from me. I've got my certified badge there, which is now a collector's item because you can't get them anymore. So I love showing that. Cool. So,
sorry, Dustin,
we don't need to
interrupt you.
Yeah.
Can you minimize the little box on the side? I'm sure people don't want to look at me.
Oh, right. Sorry. Cool.
Thanks.
Okay, we don't need any more about me. So about the title, Stateful Serverless. So this is sort of based on a talk I did in the year 1 BC, which you can appreciate is one last year before COVID. Yes, before COVID did exist, Alan. And that talk was called Azure Functions and the Actor Model. And in hindsight, there were so many concepts crammed into the talk because, we were talking about serverless, we were talking about functions, we were talking about the actor model. I don't think most of the people in that talk knew what I was on about. So I decided to name this one Stateful Serverless, which sort of, speaks more to the actual fundamentals of what we're talking about, which is basically serverless with a bit of state and then evolving it from there. I'm sure most of the folks listening will know what serverless computing is, but just so we're on the same page. So this is where there's servers running somewhere else on the cloud, someone else is managing it. The pricing is based on what we actually use. And yeah, rather than us buying and setting up things ourselves. And function as a service is a large part of this for most of the serverless providers, which is obviously what we're going to talk about this evening. But if you notice the end of that little sentence there, it says they execute logic but do not store data. And yes, that has been the case up until fairly recently. And we'll see how Azure actually differentiates quite a bit in that space, which is quite exciting and provides good opportunities. So why is the serverless thing awesome? I mean, I'm speaking from a sort of a developer perspective, right? But it gives me much less to worry about, unless you really want to worry about infrastructure, which most of the time we don't. You just want something to run somewhere. From a cost perspective, it's fantastic because you're going to pay only for what you use. You don't have to pre-provision stuff and pay for all that. And then it can still scale when it needs to. And this is one I love. You're along for the ride, right? So basically daily, these platform providers like Azure are building in new features for whether it be for security or scale or monitorability, whatever it is. If you built the stuff yourself, you wouldn't be along for that. Now you're just switching on stuff as it becomes available, which to me is really awesome. So if you want to do stateful serverless, are you in good company? Are you on the right platform? This is just a piece of a Forrester report that I got very recently. You can find it anywhere on the internet, I think, and you can see Microsoft is right up there, very close to that other company. And it seems that the main difference is around monitoring at the moment. So that whether you think Microsoft is behind sort of depends on what you're looking for. Certainly in terms of state, this is what the Forrester report says. It seems that the other provider has problems with stateful support and function timeouts. Azure is actually really good when it comes to state support in the form of durable functions, which is what we're talking about right now, and provides a really robust programming model around that state. So that's actually very cool. So before we dig into what the actual durable functions are, there might be quite a few listening that are not that familiar with what functions themselves are. So I'm going to just go through functions, the classic functions as I would like to call them, and then we can differentiate from there to see what's the difference between a durable function and a classic Azure function. So if we look at the characteristics of classic functions, they're event-driven, so that something happens that kicks them off, whether it's a HTTP request or blobbing, dropped in blob store, or an event on an event grid somewhere. It's some sort of event. These are normally relatively short-lived, so they're not going to run for hours. The limits tend to be like 5 or 10 minutes. They don't really store state. That doesn't mean they can't get to state, doesn't mean you can't connect to SQL, but they don't have native state in that process themselves. And the anatomy is basically there's a trigger, there's some bindings, which are just convenient ways for you to get to other APIs. And then there's your actual business code. That's where your logic lives. So I'm going to quickly run through a demo of building just a classic Azure function to show you how easy it is. So if I do my typical file new project in Visual Studio, just Visual Studio 2019, I go to Azure Functions and I say next. I'm going to go find a good place to put it here, which is under the UG September 20 demos classic. Just leave the default name. And this is where you can choose a trigger. So what's going to kick off this function? We know it's going to be HTTP for simplicity now. I go create that app. Shouldn't take very long. And within a few seconds, we have some boilerplate code here for an app that can basically be called and say, hello world type of thing. I can run it on my machine here. So the function tools get installed right on your machine, so you can run it locally. It's got the storage emulator, so sometimes functions need storage. The emulator can run right on your machine, and boom, we're up and running. It's listening here on localhost 7071 with some other metadata over there. So that's great. Running on my local machine is not that exciting. How do I get this up into the cloud? I literally go right click publish, choose Azure. That's function app. It's going to run on Windows because we saw lots of problems on Linux earlier. I've already created a resource group for this demo, and I've created a function app within that. So this is going to be like the container for this demo function. So hit publish. Shouldn't take too long. If I navigate to my Azure view here. So I'm showing all this, being done via the portal, but all this can be done via scripting and ARM templates and so on, of course, if you're doing proper DevOps, but that doesn't make for a great demo a lot of the time. So here's my function app. If I look under functions, there might be one there, not yet. Publish succeeded, let's see. Hello, hello. I'll just take a few seconds. Just make sure it's published. Yeah. There we go. There's my function already running in the cloud. If I want to actually test it, prove that it's running in the cloud. And click on code and test. I can get the URL. So this is the public URL of my function. I can open the logs here, so I can see I'm connected to the logs. I can open the trusty Postman and hit my API with my key, so that shows it's super secure. And if you look at the bottom, boom, there we've hit our function in the cloud now. So within a few minutes, I've got code that can scale to infinite, talk to just about anything else out on the cloud, and do whatever crazy business logic I want to do. So that is pretty awesome. Back to our slides. Why did I do that? Okay. So if that's so great, then, what's the problem? What do we need something else? The question comes, can we solve really complex problems with this, right? Can we do stuff like function chaining, where we've got bits of logic in different functions, and the one function produces some output, we push it into another function that does something specific. This is sort of the, you know, the theory around microservices, right? Everything just does its own thing specifically. It doesn't do a whole big chunk of stuff. Or interesting patterns like fan in and fan out, where I want to get, you know, I want to get quotes from 50 different providers. I want to just fan out, and then when the results come back, that should fan back in, and I want to correlate those results. That's doable today with classic functions, but it's going to be a lot of work and a lot of plumbing. Some other questions: what happens if the process needs to run a long time? You know, so maybe it's something with human interaction we'll look at a bit later. Maybe we're waiting for someone to approve something. Is your bit of code going to be sitting out there for hours and days waiting for that? You know, then you're going to be paying for that. And if not, then you're going to be writing code to save away the state, fetch the state, somehow figure out, you know, which request belongs to which bit of data. Once again, a lot of plumbing to write. And even if you could run it there and you would pay for it, what happens if you know, even though it's a cloud, your instance of the VM could go down, right? How do you recover from that? How do you continue when it comes back up, or recover in a different place? Those are the kind of questions Azure Durable Functions is going to answer for us. So what is it? It's basically an extension to Azure Functions that lets you write stateful functions in a serverless environment. This comes in the form of writing orchestrator functions and entities in the form of entity functions, and I'll dig into like exactly what's the difference between those two. Behind the scenes, it's doing all the difficult stuff, managing the state, checkpoints, restarts, and you're blissfully going along and focusing on your business logic. Obviously, as a developer, you need to understand what it's doing, right? You always want to understand the impact of what the technology is doing, but it doesn't mean you have to go and write it yourself. Actually, in detail, this is written on top of the Durable Task Framework, which, if you're at all worried, Microsoft uses this all over the show for doing their long-running provisioning, monitoring, and managing operations. So once again, you're in good company. And it comes in basically two flavors: orchestrations, which has been around a little bit longer, and then durable entities, which is basically the new kid on the block. And we'll have a look at both of them. So orchestrations. This is, I mean, if you've ever sort of, if you know the word orchestration, it's been around a long time. So if you come from maybe like a BizTalk background, there was a BizTalk orchestrations and you orchestration designer, and this was a fairly common term for stringing together long-running business processes. And this is exactly what durable functions orchestrations allows you to do, but using code instead of a visual designer. It manages a lot of that fun that I've been talking about for you. The anatomy of an orchestration function is quite interesting, right? So there's the core orchestrator function. This function doesn't talk to the outside world at all, really. All it does is call activity functions. So you're not going to be making HTTP requests straight from your orchestrator function. You're not going to be eating blob storage or files or anything from your orchestrator itself. It will just call activity functions. Under the covers, it's using industrial strength stuff. So there's actually queues sitting, Azure storage queues sitting between your orchestrator and each activity. And if you're familiar with event sourcing, it uses that event sourcing pattern to basically replay events to recreate the state of an orchestration. So that's like super efficient. It doesn't just store like a whole fat blob of state somewhere and then try and rehydrate that whole thing into, you know, this huge process. It will literally replay every single event back to the orchestration and end up in the same state. That comes with some rules, but I'll mention those later if I remember. Well, one of the rules is it needs to be deterministic, right? So you can't have stuff like random numbers, logic based on random numbers or dates that would cause the flow of the orchestration to go down a different route if those values change. So that's really important. So let's do a demo. The demo is going to be super simple. It's basically a human workflow. So this is one of the patterns that Microsoft sort of suggests is a really good candidate for orchestrations, because it can run a long time. You're going to be waiting for someone to do some sort of approval process, and you're going to be orchestrating a bunch of different things. So this is a really nice one to demo. Why is my mail? Okay. Orchestration demo. Let me just close this stuff. So we just look at the sort of structure of this solution. At the top here, I've got, actually this is not really part of the demo. So this is a logic app, but I wanted to send mail from my function, and the only binding for sending mail that I could find at the moment was SendGrid, and SendGrid for some reason don't want to give you a free account anymore. But while I'm here, I'm going to quickly show you what the logic app looks like, because this is the other offering on the serverless stack from Microsoft, which is logic apps. In this case, you actually design orchestrations with a visual designer, and this is a super simple one. I'm just going to receive a request from my function, do some parsing, and send a mail using the Office 365 connector. Another interesting thing to mention here now is that in the past, these connectors actually differentiated logic apps from the function orchestrations. But at Ignite, they announced that they're working very hard to actually make the connectors available from function apps. So you'll actually be able to use these connectors, and there's tons of them. There's connectors to connect just about anything that's out there, out of the box. So that is really exciting news, and that sort of gives you more options now. If you don't like, drawing pictures or using a flow designer, you prefer code, then orchestration functions is definitely what you want. Okay, so to get back to sort of the meat of the actual orchestration, durable orchestration, we go to this project over here. It's the leave approval project, and I'm just going to walk you through the structure of this guy. The core of it is literally, so we need something to start off the function, some sort of trigger. That's actually going to be a classic function as we demoed previously. Almost exactly the same. This has got an HTTP trigger. It's going to be exposed to the outside world, so we can trigger it. Only a little bit of difference. Maybe I should make my code a little bit bigger. A little bit of difference is this line over here. So in the trigger, we're passing in a durable client. This gives us access to the actual durable framework. So with this little guy, we can actually start orchestrations. So that's over there. If you go further down here, you can see it under this heading here. This is my actual orchestrator function. Its context is iDurable orchestration context. So it gets triggered from that function above there. I'm pulling some data out of that request. So basically, we built that request from the HTTP request. So I've got my leave request, it's going to be super simple, someone's name, number of days they want, and the date that it's going to start at. I build an email request that I'm going to pass off to an activity that's going to send the email. So if you remember, orchestration can't do anything itself. It has to ask activities to do it. So once I've got the request built there, I say context call activity async, send approval request by email. If you look a little bit further down, here's the activity. So it's called send approval request by email. It's an activity trigger. So this is how we indicate that it's an activity. It's got the request coming in. If we go back up here to our main logic, we just send that off. Okay, we don't wait. We trust that that's gone somewhere. Then we create a timeout task. So we create a timer, and from there we create a timeout task. And now the interesting thing that we can do is we can just ask the task parallel library to tell us which of these tasks finishes first. When any of them are finished, we check which one it is. If it's the approval event, we go, oh, cool, we got a response from whoever's supposed to be approving this event, and we can look at the actual result. Did he say approve or reject? If the timeout fired first, then we know it timed out. We just say timed out, and we cancel any of those timeouts. So this, in a way, is typical of that kind of a workflow, right? You're waiting for someone to approve or reject something, but you're only going to wait so long. After a day or two, it should escalate it to his, to their manager, something like that. Boom. Down here, I mentioned to you, this is just going to send the email, and it's actually just firing off the request to my Logic app, which has already been published. The actual function app, I'm just going to run locally this time so that we can have a nice, fluid debugging experience. So if I kick that guy off, I'll just wait for the terminal here, and you'll see take a little bit longer, but it's going to tell me about those endpoints that are busy running there. And we're up and going. If I now go back to my trusty Postman, I'm just going to find one of my previous requests here. So yeah, we're calling that external classic function, right? It's just an HTTP trigger function. And it's just to make sure that's something else, we'll say, Daniels. And yeah, he's gonna take long leave because it's been a hard year, 31 days. And we send that off, sending it to the local host there that's running locally. If I come back to my log here, you'll see a bunch of stuff happening here. And it should say somewhere, it'll say receive a leave request for Jack Daniels, which was just my logging information up there. Cool. So this is running locally. It should have sent an email now. I have to open my mail here for a second to get to that. If we look over there, I've got a leave request from Jack Daniels, and I'm going to click on the approve button. If you look at this link, I've got the actual instance ID of that orchestration running there. So that's sort of where the magic's happening, right? If I hit that, boom, it's just doing an HTTP GET against that address. And if we go back to our actual designer, you'll see there, it'll say leave approved. Woohoo. Now you might ask you, how did that get there? We didn't speak about that. I'm going to stop that and explain that bit to you quickly. So there was one other piece to the puzzle. While we were waiting for this external event called approve event, this guy over here was listening on an endpoint for external messages. So when we clicked on that link, it pulled the data out of that GET call. It's got a handle on the orchestration client, so it can talk to the durable runtime, and it raises an event called approve event, and for that specific instance ID. So that event went straight to that orchestration, and it carried on from where it left off. But key thing was the orchestration wasn't running all the time, right? It actually dehydrated. So if you look at the log here, you'll see a bunch of these messages are happening over and over and over. So what happens is, as the event sourcing is happening, it's replaying, it's pulling the state out, replaying all those events, but the actual activities are not firing. So we only got one email. This is the sort of the beauty of the event sourcing pattern and how the team have implemented that, which is pretty cool. Righty, so entities. This was the other flavor of durable functions that I spoke about. And these guys are heavily influenced by the actor model now. If you don't know what the actor model is, I'm going to spend like 5 minutes running through it because I really love this architectural pattern. Well, it's an architectural pattern as well as there's a bunch of frameworks that implement this pattern. What is it? Of course, it's a mathematical model for concurrent computation that treats actors as the universal primitives of concurrent digital computation. Yeah, does that make sense? Well, we're going to explain that now. So it's been around for quite a long time, since the 70s. What was that?
That's rather deep.
Yeah, it's include that. If you look at it, it actually makes sense, but why did they come up with this? So, essentially, computers are getting a lot more complicated. Everything's multi-core, and with the cloud, we've got millions of cores at our disposal if we really want to. But concurrent programming is still hard, and there's patterns out there to deal with this, like functional programming, where you don't actually change any state, everything's immutable. But the actor model is one of those things that deals with that in a really elegant way. Yeah, that sort of looks like that other definition, so I'm going to skip that one. But the key primitive here is actors. The unit of computation is actors. And what are actors? Well, they're similar to objects in OO, similar but different. You can talk to them via like a sort of an ID. So every actor has an address somewhere, some sort of ID that makes sense to your application. Its state is private. So with objects, state is not private. Well, it can be, right? Depends on what sort of a programmer you are. But there's other objects and processes can often get to that state, whereas with actors, nothing else gets to the actor state except the actor itself. A key part of it is their strength in numbers, so you can spawn off millions of these actors depending on what framework you're using. And so now you might wonder, how do these guys communicate? And it's actually really simple. How do us humans communicate without getting really confused? We have a mailbox and mail arrives and we read one letter at a time. We don't sort of read 3 letters at a time and get extremely confused. So literally these actors are running. They've got an in queue, and they take one message at a time and process it, and then run some business logic, change their own state based on whatever is in the message. What else can an actor do? Well, an actor can create some more actors. In terms of Azure functions, we use what they call virtual actors, which means that we don't actually create them. We send an actor a message and an address. If he's not there, the framework will create him for us. We can just assume he's there, which is sort of really pretty in a way. It can send messages to other actors, obviously. And then it can do the logic to change his own state. The other key thing is distribution. So we talk about location independence. You don't really care where these actors are. I know what his key, what his address is, and I send him a message. The infrastructure and configuration decides what that is. So in terms of Azure functions, this will be the sort of scaling model that you've chosen. Is it an app service where it's all running on one VM, or is it consumption where it can be running anywhere? Scale up to whatever you want, and you don't have to know how it gets found, which VM it's running on. It'll just find it. Obviously, functions is not the first implementation of it, right? It's been around a long time, so you might know some of these names like Erlang, Akka.NET, which is pretty cool if you're from the .NET space. Microsoft Orleans, which they did Halo on, Azure Service Fabric, and obviously what we're speaking about is functions. So let's just do a little deep dive into entity functions and then give you a demo. As I said, it was highly influenced by the actor model. I think this is fairly redundant from what I've just said. Yeah, and another key thing. So when nothing's happening, an entity is also unloaded from memory. So when nothing's happening on that entity, you're not consuming any resources or paying any money. It will miraculously get its message when you send it one. So I'm going to do a demo now, and the demo I'm going to do is super simple as well. Use an example of a bank account because that's often where sort of concurrency comes in. But I'm going to have a bank account entity. You can do 3 things on it. You can ask for the balance, do a debit and do a credit, just to give you the sort of demo there, the plumbing as to how you'd set up one of these entity functions. Righty, all entities. So if we come to the structure of this, once again, it's just a function app, similar to what we did previously. And if it wasn't sort of obvious previously, you never really talk to whether it's orchestration functions or entity functions directly from the outside. You've always got some sort of a surface, whether it's events happening in a blob or something. But the one that we're particularly useful to demo with is the HTTP surface. So it's literally like a REST surface that you can interact with this entity function from the outside. And if you look at if you use the ASP.NET, this will probably look fairly familiar. So I've got a get balance, a debit, a credit. I've got a root here. So this is going to be setting it account number / balance. And then, if you do a get against debit and pass in an amount, it'll debit it with that amount. And if you do a get against credit, it'll credit with that amount. The key thing, obviously, is if we drill into one of these guys, is this durable entity client, whereas previously we had the durable orchestration client. So now we've got the entity client. We get some info off our HTTP request. We build an ID, as I mentioned previously. The ID of the entity is sort of paramount in this thing. And then we ask the entity client to send a signal. So there's a couple of ways you can speak to entities, but if you look at the actor model, this is typically how I do it. Everything is sort of async one-way design, which is like highly scalable. So we just signal it. We say, this entity, please do the debit with this amount. Same story with the credit. And obviously with the balance, we've got to see if an entity exists. If it exists, we return the entity state as a balance. Super easy. Cool. If we go to the actual entity, so there's some settings you got to set here, because obviously behind the scenes, Azure Functions Runtime is managing the state. So we got to tell it which properties it should manage for us. And the key one here is the balance. So if this goes down, we'll know the balance has been persisted. It'll just come back up somewhere else with the right balance. And you can see this is modeled as a normal like .NET class, right? I've got a debit function, a debit method, a credit method, increments my balance, decrements my balance. And then you get a little bit of plumbing up at front here to basically tell the durable entity framework about this class and what methods it's got. If we fire that up, also running locally, everything cool on the storage emulator. If we can see it's busy firing up there. Second one, okay, it's ready to go. If I go back to Postman and I'll find some of those. Okay, so you can see all along here I've been using account 1. So this is literally a string. So let's do on something random. So I can say demo 01 as my account number. So get balance, that should actually complain because there's no such account number. But if I say, okay, let me just use the same account number, and I say, oh no, I made some bad ones. Okay, so now I'm going to set on that account number, credit with 50. So remember, I've never gone and created this UG demo entry in an account table somewhere in a database. All I've got is a connection string to Azure Storage. I send that off. It just says no content. Boom, done that. If I can get a balance now on that same account, it's 50, right? So it's gone off credit that entity, fired off the credit on there. If I go there now just to proved to you, I'm going to hit it another 2 times. We should have 150 balance. I send that now. I've got 150. And I could literally go and shut down the runtime now, fire it back up, come back, my balance would be 150. So pretty amazing if you think what you can do with the amount of setup I've just did. And I'm sure you guys out there can figure some amazing patterns that you could implement with infrastructure like this. Just maybe to show you what's going on behind the scenes, which I find interesting. If we fire up the Azure Storage Explorer, I'm over time. This is supposed to be the late night segment, so I should really keep you for a long time. So if I can find the account, so if I look at storage accounts locally, emulator, queues, you'll see some queues here that I didn't create. This is Azure Functions doing its thing. Chest up instances. And so essentially what happens is when you configure your functions to run on Azure, you'll just tell it what's your storage account, and that's what it uses for the queues, for the storage, for the persistence. And Azure storage accounts are like, super cost effective. So that's also really cool. Some resources if you're interested in looking into this. So obviously docs.microsoft.com. If I open that link, this durable functions page is actually pretty elaborate. If you see some of the patterns, yeah, that's what I was talking about. So function chaining, fan in, fan out. This is the one I did, yeah. So human interaction with the workflow. This is quite a cool book. So Vaughan Vernon goes into all kinds of bananas enterprise messaging patterns that you can do with the actor model. So if you did integration patterns ever, he sort of does the same stuff with the actor model, which is quite fun. If you know Vaughan Vernon, he's the guy that did the very well-known domain-driven design book, so should be familiar. And then lastly, I love these guys. So Akka.net is a framework that's basically a .NET port of the Scalar Akka framework, and also some crazy cool things that you can do with that in the enterprise space. From me, any questions? Thanks very much.
Yeah, that was really cool. Thanks for that. One question from me. I personally really like functions, and there's plenty of different hosting models. Is there any general advice you have around that? Like when choosing consumption versus putting it in AKS or ACI, stuff like that?
Yeah, so I mean, I think it totally depends on what you want to do. A lot of that is around how long you want the functions to live. So on consumption, it's fairly short-lived. If it's not durable, obviously. So if you want traffic function, you want them to live long, then you can stick it on your own app service plan, and they can run for as long as you want. Then you've obviously got premium. So like some of the issues around functions is cold starts and that. So with a premium plan, you can sort of keep 10 instances of the function warm at all times, so you never have a lag, like that. So I think there's tons of things to take into account, but almost all the sort of the pitfalls with not being able to use functions are slowly being overcome with the different hosting models. So I think it almost like whatever your need is, there's a way to do that with one of those models.
Yeah, and I just wanted to mention, like, if you want cheap, if that's your requirement, consumption model is amazing for that, because I'm not sure of the exact number, but you get quite a few free executions with the consumption model.
Yeah, 100%. And I mean, even with app service plans, so you might have a web app running somewhere and it's not really doing a lot. You can just stick the functions on the same thing and monitor it. And if it starts getting heavy, then scale out from there.
Yep. There's just one comment out here from Neil saying FYI SendGrid has a free SKU, especially when you create an Azure resource, but I found it sends out from an IP that has been blocked due to spam.
Oh, okay. Well, that's good to know.
I guess that's it from our speakers today. So I just one more time like to thank all of them for taking the time and doing demos with us today. I'm going to hand over to Alan to sort of round up and close off the session today. Thank you.
Thanks.
He shared his screen. I was prepared to do elevator music again, but I'm not sure on a risk it.
No, please, no. I'm just sharing the last slide. No more elevator music, please. Okay. Yeah, thank you to the amazing speakers tonight. We were really spoiled with some awesome content and speakers. Thank you to everyone that attended tonight. I know it's very late, but thank you for spending time with us this evening. And also thank you to the incredible online MS Doug team. And thank you to Pavendran for the awesome facilitation. If you would like an opportunity to speak at MS Doug, please submit a talk via the sessionized links that's listed on the page here. Everyone has something interesting they can share with us, and we would definitely love to hear from you. If you have any questions or further questions about content that you saw tonight, or you just want to hang out with the team, we have a networking session after this event. You can join us at akka.ms, MS Doug Networking. I hope to see you there, but if I don't, see you next month for the next MS Doug event. Have a great evening and good night.